first worksheet we're going to do today is really pretty simple. We are just determining whether the forces on this acting on this object are balanced or unbalanced and which direction they will go. If the forces are balanced, then that object's not going to go anywhere. So for the direction, we would put none. We're going to take a look at number 1. We see that going to the left, we have a force of 20 newtons. Going to the right, we have a force of 80 newtons. When we did our notes on balanced and unbalanced forces, we determined that when the forces are the same strength, we've got the same equal forces on each side, then they would be balanced. But we have 20 on one side, 80 on the other side. So we know that this would be unbalanced. And since it's unbalanced, we need to figure out what direction it's going to go. If I'm pulling on the object this way with a force of 20 newtons, and somebody else is pulling on the object this way with a force of 80 newtons, we can see it's the bigger arrow, the bigger force, so it's going to go to the right. Now let's take a look at number 2. Once again, we have two forces acting on this object. We have a force of 50 newtons pulling to the left and 50 newtons pulling to the right. If we took 50 newtons to 50 newtons, we know that those would be balanced. They are equal. So we are going to say it's balanced. And when there are balanced forces, there is no direction that it will go. It will just continue at the same motion that it's currently at. So whether that's stopped or moving at a constant speed, it would stay the same. So we are going to write none for direction. You'll continue solving these for the rest of the problems on this worksheet. Our second worksheet has more drawings. We will do 2 of these together. We will start with number 5 and then we'll do 6 as well. So here we have 101 newtons pushing to the right and 29 newtons pulling to the right. When we did our balanced and unbalanced notes, we talked about how when they are going opposite directions, we subtract. If they're going the same direction, we add. So right here we have them both going the same direction, so we are going to add 101 newtons plus 29 newtons. On this paper, we are always wanting to find the balance or the net force. So that's when we use our subtraction or addition. So we have 101 newtons plus 29 newtons. That gives us 130 newtons. We always want to make sure we're labeling each and every number. So on this line, we are going to write 130 newtons. It's always good practice just to make sure you know which direction the box would move. In this case, it would move to the right. So we're going to add our little tippy-toe triangles to show the direction of movement. Number 6 here has 4 different forces. When we talk about forces, they always operate in pairs. So we're going to start pairing them up like this. So we're going to take this as 2 different problems. So we're going to start with the forces going up and down. As I said before, when they're going opposite directions, we subtract. So we have up and down, they're going opposite directions. So we have 9 newtons minus 9 newtons, and that gives us 0 newtons. So our up and down is balanced. So there would be no change in motion. So I'm going to just write our little tippy-toe triangles showing no change in motion. Now if we look left and right, these are also going opposite directions at 9 newtons. So I'm going to do 9 newtons minus 9 newtons. And once again, we have a net force of 0 newtons, which would mean there's no motion. So on number 6, because they were both 0 newtons, our overall net force on this would be 0 newtons. The back side are word problems. Now when you're given a word problem regarding forces, we want to make sure that we're spending less time on drawing accurate pictures for the scenario and making sure that they're more accurate in terms of forces. So we're talking about a soccer ball here. All I'm going to do is draw a circle. You could always draw a box if that's easier for you. We see that Shane kicked the soccer ball at the goal with 95 newtons. So he's kicking this ball. It's going this direction with a force of 95 newtons. The goalie blocked the shot by hitting it with 115 newtons of force. 115, we know that's bigger than 95, so we need to make sure that our arrow going this direction is a little bit bigger than our arrow going the other direction. So we have 115 newtons acting on the ball this way, 95 newtons acting this way. Once you've got this part drawn, it's really pretty similar to the front side of this worksheet. We are going to try to find the net force. We want to determine if the forces are balanced or unbalanced. We have different numbers here, so we know right away that these are unbalanced. We also know that the ball is going to move in the direction of the larger force. So we have 115 newtons. I'm going to draw my little tippy-toe triangles to show the direction that this ball is going to move. So we have our arrow with a matching force, a bigger arrow here with the bigger matching force. The only thing missing is my net force. So we're going to take the bigger force, which is 115. These are going opposite directions, so we know that we need to subtract. So I'm going to do 115 minus 95 newtons, and that gives us a net force of 20 newtons. So in my net force, I'm going to write 20 newtons. You'll continue to do that on all 4 of these problems. When you get to Ashley, she is helping her mom carry in groceries. There are going to be 2 drawings here, one for her left hand, one for her right hand. So you'll want to make sure that you've got both of those drawings there. Go ahead and draw your forces. Make sure you include these 5 things. The arrow with the right force, the other arrow with the right force, the tippy-toe triangles, your problem, and your net force. Good luck. Let me know if you have any questions.